Okay, so we are now talking about confidence intervals this unit. So confidence intervals, if you ever read a report that's based off statistics, they're going to say something along the lines of, we are this percentage confident of blah, 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 okay? Medical reports have a lot of that. And so we're going to talk about how it is you find that, what it means, and how to interpret it, okay? So two major techniques for testing: confidence intervals and hypothesis testing. So we're doing confidence intervals now. Hypothesis testing is next chapter. We're going to be talking about statistical inference, which is the process of drawing conclusions about a population based on sample data. The purpose of collecting data on a sample isn't just to have the data, it's also to take information and to interpret it, obviously, okay? So you can make an inference about the population based off of the information from the sample, which is kind of what we've already been doing. And for confidence intervals, we use data from the sample statistics to construct an interval we think contains the population parameter. Remember, a parameter goes with the population, a statistic goes with a sample. Confidence intervals estimate the value of a population parameter. They do not estimate the value of a sample statistic or of an individual observation. So when you're talking confidence intervals, we are talking about the population, not the sample or an individual.
Well, the hypothesis.
If you want to read Garfield, you can go ahead and read Garfield. No.
In the notes.
A confidence interval is an interval of values computed from sample data that is likely to include the unknown value of a population parameter. There's no guarantee that a given confidence interval does capture the parameter, but there's a predictable probability of success known as the confidence level. Common confidence levels would be 90%, 95%, 98%, 99%. Those are ones that we see a lot. I can give you any confidence level, but those are going to be occurring rather frequently. So the confidence level, is a measure of how confident we are that the confidence interval contains the true population parameter. So if your significance level is alpha, 5, okay, 5%, then your confidence level would be 1 minus that. So 95%, okay? This tells us, like, after repeated sampling, 95% of the confidence intervals constructed would contain the parameter of interest, and 5% would not. So when you're looking at this is saying we have all these different samples, okay? And what that confidence level says is, I am confident that 95% of the samples we took will have the information that we're talking about. Does that make sense?
Yes.
Yes? Okay. So if we select many different samples of size n from the population parameter and construct the corresponding confidence intervals, 95% of them would have that parameter in it. So to find confidence intervals, we first need a point estimate. And you also need the margin of error. So if you've ever seen something talking about margin of error, it always says this plus or minus this, right? The first number is your point estimate. That's saying you're saying the middle of the number, and then plus or minus either side of it is your margin of error. And then your confidence interval is basically your lower bound and your upper bound. So all of this sort of connects together. A point estimate is a single value used to estimate an unknown population parameter. So when we're talking about the sample proportion, p hat would be your best point estimate. If we're talking about sample of means, x bar. So we're using those same numbers and they represent the same thing like they did last chapter. We know that it's not going to be exactly the same value in your sample that represents the population, but it should be close to it. That's what we're saying, is we are this % confident that the number we're picking is this close to the actual value. Does that make sense? Yes? Okay. The half width of a confidence interval is called the margin of error. And that's represented by E. Okay, so your error to find proportions, you're going to use Z star and then multiply it by what you should recognize that formula, square root of P times 1 minus P over N.
Z formula, right?
Huh?
Isn't that our Z formula?
That's standard deviation, yes. And then for actually not, and it's not for proportions, it's for population means. T star times S over square root of N. So again, that should look very familiar because that's your standard deviation for population means. And Z star and T star are known as critical values. So if I ask you for the critical value, I'm asking you for that number. And we're going to talk about how to find all this. Okay, so things that affect your margin of error. The level of confidence is one thing that affects your margin of error. As your confidence level increases, the margin of error will also increase.
Oh, so you want a smaller level of confidence.
So if you look at this information right here, narrower but riskier, I have an 80% confidence level is a narrower confidence level, but it is going to be riskier because it means you have a smaller percentage of getting that information. If you go with a wider confidence level, then it's a safer confidence level.
Margin of error is bigger, but you have a higher chance.
I mean, think about it. If you said to me, Miss G, what's the probability I'm going to make an A on this test? You want me to say a 95%, but the chances are I'm going to say an 80% because that's safer. Does that make sense? Yeah. So that's sort of not exactly the same, but it's kind of in the same genre of what it is that this is talking about. The smaller the percentage, the safer and more likely your answer is correct. Which means when you're looking at any sort of statistical information, data that they say 95% confident, that is very narrow, which means that they have the statistics to back it up. You hope. Okay, the other thing that affects margin of error is your sample size. Obviously, a larger sample size will produce a narrower confidence interval when other factors remain the same. In this case, we generally say our estimate of the population parameter is more precise. So think about that. If I have a larger sample size, remember that means that my standard deviation is smaller because I'm taking a number, dividing it by a bigger number, right? So that's why a larger sample size gives me a narrower confidence level, which is why when you're doing any sort of statistics, you always want to have a large sample size because it helps you get more accurate data. And then this is just a visual example. If you have a sample size of 2,401, you could say your margin of error is 2%. Sample size of 1,067, margin of error 3%. And then you just notice how much smaller the sample sizes go as you get a larger margin of error. Okay? Okay, one thing you do have to remember is you have to remember to make sure that we can use a normalized chart in order to be able to use our data. So you have to check, make sure, does it actually follow my guidelines? The majority of the time it will, but you still always need to make sure that you check it. So remember, for proportions, must be a random sample, which means, and then N times P hat must be greater than or equal to 5. And remember, 1 minus P hat is Q hat, so N times Q hat must be greater than or equal to 5 for proportions. For sample means, it has to be a random sample, and the population either has to be normal or your sample size must be larger than 30. All right, so confidence interval, again, is your point estimate plus or minus the margin of error. So to look up, I want us to practice looking up because I'm not going to give you this chart that I'm going to write down, but I'm writing it down for you to use if you want during like homework and notes and stuff. But you need to understand how to find these answers from here. So if I have a confidence level of 90%, what that says is that the middle 90% of my bell-shaped curve is what is included. So what numbers, think about that. What numbers am I going to?
5 and 95.
5 to 95. Does that make sense? So when I look at my Z chart, I am going to, where do I have a 0.95? What Z value gives me that? So I go look at 0.95 and I'm going to find that it is 1.64. So my Z star would be 1.64 for that. And again, the reason why I'm telling you that is these four numbers I'm talking about are the ones that we use the most often. But you need to understand how to find it because you have to know how to find it on the quiz and test. All right, so I want you to go find your Z star number for 95%, 98%, and 99%. Remember, when you're looking at them, use the one to the left when it's between two numbers. Okay, so for 95%, your Z star should have been 1.96. For 98%, you should have gotten 2.32. And 99% is 2.57. So you can write confidence intervals one of two ways, and you need to know both of them and be able to do both of them. They're not hard, okay? You can write it as an interval. An interval is with parentheses, and you have the lower bound to upper bound. So, for example, 85, 95, okay? That would be an example for an interval. Or it would be an inequality, which is the lower bound less than your parameter, which parameter is either p hat or x bar, and then less than your upper bound. So think of it as domain, guys. It's exactly the same thing, okay?
And is it the confidence level domain that we're doing? So like the...
All right, so example one. So here's some very basic questions. Find the confidence interval given the point estimate and the margin of error. Write the answer in both interval notation and inequality. So write the confidence interval for a population proportion P if the point estimate is 0.72 and the margin of error is 0.14. So that's saying the point estimate, the middle is 0.72. Your margin of error, your high and your low is 0.14 above and 0.14 below.
So you just subtract 0.14.
You're adding and subtracting. So 0.72 minus 0.14, 0.72 plus 0.14. So writing it as an interval is going to be 0.58, comma 0.86. Writing it as an inequality, 0.58 less than P less than 0.86. So whichever way, I may ask you to do it both ways. I may ask a specific way. I may not tell you, and you get to pick which way. So just make sure you can do it either way. So everyone go to letter B. Write the confidence interval for population mean mu if the point estimate is 48.7 and the margin of error is 5.24. So go do both an interval and an inequality.
You didn't do bad with it.
Yeah, I got 11:15. That's when I got 12:60.
Oh,
Oh
shoot.
yeah. Guess what?
You have 12,
Guess what? At 11 p.m., all of our tests auto submitted.
For what?
The SAT, no matter where you were, the test submitted.
Were you done?
No.
You took it at home?
No. I had blue book and stuff crashed. Everyone's test submitted at 11. So they emailed us a preview of our scores. Or just like, if you want to keep your scores, you can. And I saw 12.6. I was like, bro.
Okay, so in April 1998, the Marist Institute for Public Opinion surveyed 883 randomly selected American adults about allergies. According to a report posted at the Institute's website, 36% of the sample answered yes to the question, are you allergic to anything? Construct a 95% confidence interval to estimate the population proportion of all American adults who are allergic to something. So, first of all, are the conditions met? Is it random?
Yes.
What is N times P hat? So that's 883 times 0.36. That gives me 317.88. That is greater than or equal to 5. So that is met. Then do n times q hat. So remember, q hat is 1 minus p hat. And you get 565.12. Again, greater than or equal to 5. By the way, when I'm giving you a problem about confidence intervals, I'm not necessarily going to ask you to do all these steps, but these are the steps you are required to do no matter what, okay? I'm walking you through it on the first one, and know that you always have to do that for every problem, okay? Even if I don't ask you, even if all you do is do it in your head, you need to see, does it meet the conditions before I start this problem, okay? All right, the critical value. So what is my Z star? So remember, we're saying a 95% confidence level. So we just found that it is 1.96. And again, you would go and look for what is 0.975 or 0.025 on there and find that Z value, okay? Okay, the calculations. So this is where I'm going to use p hat, which p hat is, so if you need this, by the way, 883 is in, p hat is 0.36. Your formula is p hat plus or minus z star times p hat 1 minus p hat over n. So remember, this is your E, your margin of error. That's how we found that. I gave you that formula. You're taking your point estimate, which is p hat 0.36, and doing plus or minus margin of error. That's what that formula is. Okay, it's not complicated. It just looks complicated if you don't know what it means. So 0.36 plus or minus 1.96 times the square root of 0.36 times 1 minus 0.36 over 883. So in case you've forgotten how to do this with the calculator, you're going to do 0.36 minus 1.96 times square root of this, enter, and then arrow up, grab that equation, and change your minus to a plus. So the first one's going to be your lower bound, the second one's going to be your upper bound. Okay? Or if you want to do it in pieces, that's fine, but I mean, if you've got a calculator, my recommendation is just plug it all in. So do that and then make sure you're actually getting the numbers. We're going to go ahead and do, unless the problem states specifically, we're going to do 4 decimal places. Okay, my conclusion. This is where the writing comes in. Okay, we are 95% confident the population proportion of American adults who are allergic to something is between 32.83% and 39.17%. Next one. Find the critical value for a confidence interval in which we are 88% confident. Okay, so we're talking the middle of it is 88%. So that means I have 6% on either side. So I'm looking at 0.94. So what Z value?
1.55.
1.55. There's your answer.
I already had that answer. I just wanted to get one right for the first time.
All right, suppose you obtain the confidence interval 0.7263, 0.9352. Can you tell me what the point estimate is? And can you tell me the margin of error?
You just go for the higher one, right?
So what's the point estimate?
It's in between.
It's in the middle, so find the average. Average of the two numbers.
By two.
Yep.
Don't we just convert to a Z-score?
No, this is asking not z-score. This is, I'm giving you the answer. Can you tell me what the point estimate and margin of error are?
Oh.
Does that make sense?
Oh, I was thinking this was like the.
0.8308. And then what is the margin of error? So this is where you would do the high minus the point estimate. The upper bound minus the point estimate is your margin of error.
Hey, can we be quiet over there? We're trying to do math.
No, it was asking what. So in other words, it's saying what if I did blank plus or minus blank, what numbers go in those blanks to find that confidence interval? Does that make sense?
Oh, I got you.
Okay, a two-lane highway with a posted speed limit of 45 miles per hour is located just outside a small 40-home subdivision. The residents of the neighborhood are concerned that the speed of cars on the highway is excessive and want an estimate of the population mean speed of the cars on the highway. The Department of Transportation estimates that 2,400 cars travel on the highway between the hours of 9 a.m. and 3 p.m. The residents decide to measure the speed of 12 cars on the highway during non-peak times. The 12 cars will be selected using a simple random sample by determining numbers between 1 and 2,400 and measuring the speed of the cars using a radar gun. The data below shows the speeds in miles per hour of the 12 randomly selected cars. Construct a 90% confidence interval about the population mean, nu. Assume the population standard deviation speed is known to be 8 miles per hour based on past studies. Okay, so all of that information, what is it that we need to know? First of all, we need to know that N is 12. Okay, my sample size is 12. I know that
Confidence level.
my population standard deviation sigma is 8. Now I have to find everything else. So I am giving you data, and you have to find the average. So,
Confidence level, right?
yes, we're doing a 90% confidence interval. Okay, so you can either do this by hand, or if you remember, which you should, how to find information using stat edit.
Oh, yeah. Somehow I figured out how to do it in the middle.
So you click stat edit, enter in the data in L1. If L1 has data in it, highlight L1 and hit clear, not delete, clear, and then hit enter and it'll clear out all the data.
Does it matter the order at which?
Wait, where'd you go?
Once you have your data in L1, you're going to do stat, arrow over to calculate, and you're doing one variable statistics, one var stats. And then that's going to give you, remember we are looking for, in the calculator, mu is actually x bar. That is your mean. Now, if you needed it, we'll talk about which one of the standard deviations you use, but this problem gave me the population standard deviation, which I needed. So I'm not using what was in the calculator for that, because that's your sample standard deviation. Okay, so you should get mu is 59.62, unless I did it wrong in the calculator.
I got
Yes?
it.
Okay.
Well, I thought we went 4 decimal places.
All right, 90% confidence interval gives me gives me a critical value of what?
0.975?
It's on.
No,
it's
like we're
one-
So I get 1.64. Now to find my confidence interval, I'm going to do mu 59.62 plus or minus 1.64. This one is sigma over square root of n because it's sample means, not proportions. So times 8 over the square root of 12.
Will you give us?
At least everyone is wearing their shoes. That's a win.
It's also the one with, it's also the
Everyone
one
just
with,
goes through
Oh,
Wow.
wow.
I'm not ready to graduate.
yeah, the little dandelion or whatever it is. The elephant. Yeah.
Okay. Example 6. A simple random sample of size n is drawn from a population that is normally distributed with population standard deviation sigma equals 13. The sample mean x bar is found to be 108. Compute the 96% confidence interval from mu if the sample size is n equals 25. So go.
Bro, I.
Okay, and then we just have to mark it out.
I wanna hear.
I got 102 and 113. Yes, give or take a bit. Cool.
With a few decimals behind it.
On to the next.
Jackson, you're not going to college anymore.
So it's the same thing, we just changed 25 to 10, right?
Yeah.
Connor Carter, good boy. I feel like his name's,
Okay. And we do the same thing.
Not greater than 30.
Yesterday, Shorty snotted a big snot.
Another one?
And he snotted. I was laughing for like 10 minutes. But he snotted a like 4-inch.
Shorty's nasty.
It's bad right now. His allergies are acting up.
what about, Olivia's friend?
Hopefully he doesn't like get pneumonia. Because I can't have both dogs dying at once. That would just be.
So it told us in the problem that it was normally distributed, therefore we didn't have to worry about the conditions. However,
He's like,
if it had not been normally distributed, if it did not tell us that, why not?
It's not greater than 30.
So remember, it's either that it has to be normally distributed or your sample size must be greater than 30. Therefore, no, because the sample size is too small. Okay, 2 more problems. I'm going to have you do both of them real quick. I need you to change some words. So change, it says a sample standard deviation, change that to a population standard deviation. And then delete the last sentence, should we consider the drug a success? I don't want you to worry about that right now.
What about, it says sample mean.
That is okay. The reason why is next class we're going to talk about what happens when you don't have the population standard deviation. You have to do it differently. But this one, it
I
is
think you changed ours. I think, yeah. You already fixed ours.
same thing on example 8. Change that to be the population standard deviation. It doesn't say it, it just says standard deviation, which would imply sample. And then now I want you to go find those 2 answers.
90% confidence.
Wow, this interval's tiny.
1.64. That's 95. This is 90. Yeah, one day I'll get there. Oh, 30 drugs.
Oh, yeah, you're right. Go left.
Are you solving these questions right now, Misty, or have you already solved?
Bless you.
Bless you. Bless you.
Thanks, guys.
God bless you.
Feel very blessed.
Coleman, Austin just said you're very pretty eyes.
I did.
You're welcome.
I don't feel the same about you.
Oh my God.
Aw, poor